So we're talking about quadratics today, and I am graphing one. That's different than sketching one. Sketching, I could just be like, woo, and then that kind of looks like a quadratic. But actually graphing one, I need to have distinct points like this. There, I graphed a quadratic. Now you have to know like 10 things about them. There's the x-intercepts and the y-intercepts. You have to know the axis of symmetry, and you have to know the vertex. You also have to know whether the thing has a maximum or a minimum. So let's talk about all of those things so that you know kind of the main terminology. All right, so this thing down here, that's called the vertex. I think you know that, don't you? That's called the vertex. All right, so the vertex of it, you know what always goes through the vertex? Every single time, it always goes through the vertex. That little dotted line, that's called the what of what? Line of symmetry, very good. But you've grown up now, and it's got a name that's more official. It's called the axis of symmetry. The axis of symmetry is always an x equals thing. And I want you to process this. I know it's on the y-axis, but that line is called, I said it before, do you remember it?
X equals 0.
X equals 0, good. The y-axis is the line x equals 0. So if you want to graph that ever, which sometimes you do, you have to type x equals 0, and it'll graph a whole line. The number 5 doesn't mean anything on a graph like this. If I just said 5, would you know where it was? No, you can't tell. You can't tell if I meant x is 5, y is 5. The line that goes through 5, it doesn't mean any of those things. So just a single number on this whole chapter test that's coming up, the next one, on quadratics, a single number is always wrong. When it comes to quadratics, if you say the answer is 5, you're wrong. It was either x equals 5, 5 comma 0, which is a point, 0 comma 5, which is a different kind of point. One of those is an x-intercept, one's a y-intercept. Okay? So the answer is never just 5. Never just a number. It's always going to be like x equals that, or y equals that, or a point. All right, so what is the vertex? It's 0 comma 0. That's the vertex. It's also, this is a weird one, because normally they're all different. But in this case, the vertex is the same as the x-intercept, which is the same as the y-intercept. Right? Because it touches the y there and it touches the x there. It's the only place where you can be all three things at once. You could be the vertex, and you could be the x-intercept, and you could be the y-intercept. So I think we should make another one that's a little more normal. And we're going to put it over here. And I'm not going to make you graph that many points. We'll just graph 3 points. Remember, it's not a V shape, it's a U shape. Now that one, its vertex is different than its x-intercept. And the axis of symmetry is always an x equals thing. So the y-intercept, I can't even tell because I'd have to go up so far to get the y-intercept. It would be ridiculously high. So let's just ask on this one, can you just tell me what the x-intercept and the y, sorry, not the y-intercept, the x-intercepts and the vertex and the axis of symmetry? Hint, the x-intercepts are points. Hint, the axis of symmetry is an x equals thing. And the vertex is a point. Now, some of you guys just had disappointing results on your cumulative tests. Most of you did great. The median, which is the middle score, was a 90, and the average was an 88, which rounds to 90. So that's pretty darn good. And most people actually had, it helped their grade for most people. But for some of you, it was like, oh, it just bombed that test. There's two reasons for that. For some people, you really just didn't understand this stuff, and you never figured it out. Okay. There was a few other people, though, that got a low score, and you look at it and go, oh, I can't believe I made so many dumb little mistakes. You're like, oh, I forgot the thing was upside down, so there's a negative. In this case, are either of these parabolas upside down? No. So there's no negative on the equation for them, is there? All right. Next thing, x-intercepts. That's 1, 2, 3, 4. If I just wrote 4, did I pound that drum hard enough? That is not the answer. You can't just write 4. Even though that is 4 there, you got to say the x-intercept. That's where y equals 0. 4, comma 0. And the other spot is 6, comma 0. If you ever just find yourself giving a single number answer, check yourself. All right, the axis of symmetry, again, you might think, well, what's right between 4 here and 6 here? That must be 5, and you just write 5, and kids are going to do that on the test. Then I'm going to mark it wrong, because what's the actual answer? X equals 5. It's a dotted line that runs right down the middle of it. It's a lot like an asymptote. It's not an asymptote, but it's like it because you use a dotted line for it, and it's up and down like that. Okay. And last but not least, the vertex. That should have been the easiest point. It's like right there, and it's at right between 4 and 6, so it'd be 5, comma, negative 1. Notice none of those answers were single numbers. Okay, cool. Now, next is, do you get I could write an equation for this? There is an equation for this. There's be some equation, y equals, and it's got an x squared in it somewhere. That's what parabolas are. But there's 3 different forms of equations that you have to know. One is if it's like this, in what's called factored form. And I bet you're going to catch on to where I got this. X minus 4 and x minus 6. Can you see where I got that? Because the x-intercepts were 4 and 6. Look at that, x minus 4 and x minus 6. And it's factored, my favorite thing. So much so that somebody made a poster for me. If you can factor it, you should. Because if you have an equation and you could factor it, boom, you now know the x-intercepts of it, which is pretty cool. You also know the answers, which are called the zeros, which are 4 and 6. Those are called zeros because when you stick them in the equation, it makes the equation equal 0. All right, so anyway, that's factored form. One thing I know you can do for today that you already know coming in is how to multiply that out. Take a second, multiply that out. One of the reasons you're good at that is that I made you do the silver 20. And this is where that's going to start to pay off. Because a bunch of the things from the silver 20, which you have pretty much mastered by now, are little things that are in this unit. So by doing a little bit of work ahead of time, made you work really hard the first few days in this class to learn all those silver 20 things. I won't have to now reteach you how to multiply this out. X squared minus 6x minus 4x plus 24. And if I actually simplify that down, y equals x squared minus 10x plus 24. Raise your hand if you had that one right. Awesome. And if we hadn't done that silver 20 work, tons of kids right now would have that wrong, and now I'd have to spend 10 minutes explaining how to do that. All right. So that's called factored form. What's this called? I said it once. If this is factored form, what's this form? General form. And then there's only one other form that exists that you know about, that you're going to have to know about. And that is called vertex form. Neither one of these two is in vertex form. The white one's not in vertex form. The red one is just the not simplified green one. And that's not vertex form. Vertex form, surprisingly enough, uses the vertex. If I rearrange this equation to do this, wait. There. I bet some of you are going to know how I got that vertex form. Do you see the correlation with the vertex? Does that make sense to you? See, I took the vertex of the 5, -1, and I put it in, and you might be like, but you used the -5. It's because you don't trust the inside. You do the opposite of what you expect in the inside. You don't use a +5. You use a -1. And this -1, the y values you generally can trust in. Look at that, I can trust it. It's on the outside. All right, there's 3 forms. The white one that I just did is called vertex form. The white one that's got the 2 sets of parentheses, that's called factored form. And then the green one at the bottom, that's called general form. All right, now there's only one other thing I have to teach you today. And then we'll practice it a little bit. And then we're done. Cool. The last thing I have to teach you today is how you can tell whether the parabola has a minimum or a maximum. If you can just look at it, I bet you will know, without me even saying, does this parabola have a vertex that is a maximum point or is it a minimum point? I've never told you this, but I bet you can figure it out. Is it a maximum or is it a minimum? Talk to the kid next to you and see what you do. The vertex here, is it a maximum or is it a minimum? It's a minimum. Minimum means low point, and almost everybody was, I heard you mumble to the kid next to you, minimum. Yes, it's a minimum. Okay. So a minimum means like the lowest spot. Does every parabola have a lowest spot? No. What if they're upside down? Because see, if the parabola is like this, then it doesn't have a minimum. It doesn't have a lowest spot. Instead, it has a highest spot, which is not called highest spot. What do you think it's called? Maximum. You get how that makes sense? Every parabola either has a maximum or a minimum. Now, if you're looking at them, I know you'll know this. Every kid would get this right if the question on the test was, look at this graph. Does it have a max or a min? Everybody can do that. They'll be like, that's a max and that's a min. Everybody gets it right that way. But if I give it to you this way, some kids are going to be smart enough to go, oh, I know right away whether it has a maximum or a minimum. And other kids are going to be lost. I will teach you, and then you just have to learn this. But how many of you already know whether this thing has a max or a min? Raise your hand if you're like, I know. All right, 2 kids timidly, not quite sure, but they think they know. And then tell me, what do you think tells you whether it has a max or a min? The negative. All right, with that clue, he's saying the negative tells you. Now, can you tell me whether this will have a max or a min? How many of you think you know now? I promise not to call on you. How many of you think you know? All right, we're up to like 8. Here's why they know and some of you don't. Because the negative means it must be upside down. As soon as you know the negative means it's upside down, then can't you tell that it has a maximum? So I like to just say this guy's name right there, if there's ever a negative in front, his name is Max. For some reason that works for me. If I see a negative, I'm like, oh, that guy's name is Max. He's a Max. So this parabola has a max. So it's super simple. If it has a negative, it's a max. If it doesn't, it's not a max. So if it's like this, the red one, that one has a maximum. The other one, it doesn't have a maximum. So it must have a what? Minimum. All right. So it's either got a maximum or it doesn't. And again, the reason is if there's a negative in front, the whole thing's been reflected upside down, and therefore it will have a maximum. All right, let's see if you learned anything. I got 5 questions for you. If you can do these 5 things, then you understand everything. All right, don't draw this, just answer my questions about it. If I have a parabola that is upside down and goes through those points. In fact, I'm going to be really more careful with this next one. I'm going to actually make it have a y-intercept. There it is. Tell me all the things I just told you. That is at least 5 things I told you. I told you you had to know the axis of symmetry. I told you you had to know the vertex. I told you you had to know the x-intercepts, the y-intercepts. Write them all down. This is your last thing you have to do. If you're having trouble with motivation, this is it. Then we start the homework. You should know the vertex. You should know the axis of symmetry. Hint, it's the axis of symmetry. You also need to know the y-intercept. And by the way, none of these things, none of them are a single number. If you think I'm going to write down 4. Nope. For instance, -2 is involved in some of your answers, but the answer is never -2 here. All right. And then, this is the stretcher one. Can you write me the equation for this in factored form? Hint, the x-intercepts tell you what to put. Can you write the equation in vertex form? I'll give you an example, but it'll be wrong on purpose. That's kind of like vertex form, but I used the wrong vertex. And can you write it in general form, which the way you get that is by multiplying one of the other ones out. You can multiply either one out and you'll get general form. All right, that's everything. I know this is early. We've only gone like 18 minutes into class. I don't expect you to be an expert yet, but I expect you to know some of it and be a little lost on some of it. And then when you compare with the kid next to you, hopefully you can fill in some of those holes and figure out like where you're weak. Maybe they can help you. All right, I'm going to pause for a minute while you try to answer all those questions. X-intercepts, y-intercepts, axis of symmetry, vertex, and then those 3 equations. I know I'm stretching you, but I think you can do it, at least with help. All right, so here we go. Vertex, -2, 1. The x-intercepts, that one is -1, 0. And I just checked myself. The x-intercept is where y equals 0. Did I make y equal to 0? Yes, I did. The other one, the other x-intercept, is -3, 0. Those two, this one and this one, can make me write x plus 3 and x plus 1. Did anybody catch that? That's how you could get factored form. Some of you caught that. Awesome. If you didn't catch it before, catch it now. Those x-intercepts, they tell you factored form. Okay? If you multiply that out, you can get general form. But first, let's clean this one up. I told you that was wrong. I told you it was an example of how the vertex would go. And I heard one kid say, I think we should use x plus 2 because you don't trust the inside. And he was exactly right. And then the 1 that's on the outside, we can trust that, and it's +1, and it looks like +1. But there's one more little catch that I know some of you forgot, but some of you remembered. Who can tell me what I'm talking about? If you know, you know. You remember? What? Has to be a negative in front, because look, it's upside down. And I know tons of you forgot that, and that's going to happen on the test, guaranteed. Tons of people are going to forget that, oh crap, it was upside down, I needed a negative in the front. Did anybody actually have the negative there? I'm curious. Oh my gosh, only 2 people. All right. That's an easy mistake, isn't it? When everybody in the room just forgot, except for 2 people. So don't let it happen to you. Check for whether or not it's a max. See, this is a maximum point. And if it's a max, there should be a negative in the front. Okay. And then last but not least is multiply them out. It doesn't matter whether you multiply this one out or this one out, you're going to get general form. Either way, they come out the same, which is kind of weird. So then what's missing on the top one? There must be something missing, otherwise they wouldn't come out the same. There's a negative. Again, it's upside down. Factored form, the x-intercepts, they come from the x-intercepts. Like that point told me that, and that point told me that, but it's upside down. I gotta have a negative in front. Now, if I multiply either one of those out, I will get general form. I suggest the top one. I think it's easier. Take a second, multiply that up. Do it. Weirdly though, if you multiply out either one of them, they will come out to the exact same general form. Now, if you're thinking, I tried the bottom one and it doesn't come out the same, that's because you're doing it wrong. If you were going to multiply the bottom one out, do you remember that the x plus 2 squared actually means x plus 2 and x plus 2? And then plus 1? Tons of people forget that. They think, oh, I'm just going to square the x and I'm going to square the 2. No, it doesn't work that way. All right, but I'm going to do this one. I told you that was the one I would do, the top one. And here it is. X times x, x squared. I'm leaving that negative for later. And I'm going to multiply everything I have by the negative later. Plus 1x plus 3x plus 3. Now, some of you, I understand, early on, you didn't know what the silver 20. We've already covered 3 things that are skills in that silver 20. And if any of these are things that you're weak on, you need that silver 20 to be strong. I'm going to be pounding on that in conferences. If your kid's still getting like a C on the silver 20, that means their algebra's weak. Guess what we need for this next chapter? Tons of algebra. Tons of algebra 1. And this kind of thing, multiplying these out, it's on there. Got to know how to do that. Okay, negative x squared. This is my final answer here. Now I'm going to put these two together and call that 4x. Then I put the negative on it because I'm distributing the negative. It'll be negative 4x minus 3 because I distributed the negative to the 3. Now, it's not like what we just did was that hard. It was a lot of little tiny steps and a lot of chances to make a little mistake. All right. That's called general form. Please underneath it write gen form. General form. So you got 3 forms to know for today. General form, vertex form, and factored form. And then you got to be able to know all these little words like vertex, axis of symmetry, x equals negative 2, y-intercept, (0, negative 3), x-intercepts, which we already talked about, all those little words, and then that's it for today. Cool. All right, so let's use your final test. Do you know? What form is this in? That is vertex form. Everybody take a second, write that down, say V form. What form is that in? Factored form, F form. And if I actually multiply that out, which I will, x squared plus 7x plus 8x makes 15x. X squared plus 15x plus 7 times 8 is 56. There, I multiplied it out, and now I've got the what form? General form. G form. I'm fine with abbreviations because I know what you mean. On that top one, the vertex is just sitting there. The most common mistake would be 3 comma 8. What's it actually? Negative 3, 8. And these two things, it's very tempting to say the x-intercepts were negative 7 and negative 8. But you're not allowed to say a single number. So if it's not negative 7, it's actually negative 7 what? Comma 0. X-intercepts of y equal to 0. And then this one would be negative 8 comma 0. Okay, cool. Now you're totally ready. To start with, find the worksheet. And then try to remember this. On the worksheet, the last one has a mistake in the key. And so we're not doing it. I was going to have to skip something anyway. I'll just skip the one that has the mistake in the keys, so you won't get messed up later. The last question is like a big graphing question. Skip it. It's actually way more complicated than when you do on a test, and there's a mistake in the key. So. But the first question is then the second and the third, fourth, fifth. Those are all fine. So what's the very first question? Jack Breen, would you read me number 1?
It says for each of the graphs below, identify the vertex, axis of symmetry, and axis intercepts. Let's look at the picture.
And axis intercepts. That is a term that covers both x-intercepts and y-intercepts. So if you write 2 comma or 3 comma 0, I know whether it's an x-intercept or a y-intercept. Do you? Because it has a y equals 0, it's an x-intercept. So you can just list them all together there, and I'll know which ones the x-intercepts are, because they'll have y equal to 0. And I'll know if you put right next to it 4 comma 0 that you mean that the y, no, that's another x-intercept because it has a y equal to 0. But if you put 0 comma 2, then I'll know that's a y-intercept because its x is equal to 0. So basically, you can list all your key points there, and I'll know by whether you say comma 0 or 0 comma, whether or not they're the x or the y intercepts. All right, so Jack, can you help me out with, and we'll see if the crowd agrees with you, what do you think the vertex of that thing is?
-1, -4.
Do you guys agree? Cool. Then the axis of symmetry, I can know without even looking at your picture that the answer is x equals, because it's the axis of symmetry. And then I actually know x equals -1. Can you tell me why I could know that without even looking at your picture? Because it has to go through the vertex. Do you ever notice that? The axis of symmetry runs right through the vertex, and the x of the vertex would have to be the same. That will always work. The axis of symmetry is the axis of symmetry. And what's the x? It's -1. Cool. And then the last thing is you have probably two x-intercepts and one y-intercept. And if they're x-intercepts, they're going to have a y as 0. And if they're a y-intercept, they'll have a 0 for an x. And then hopefully you know what those are. Okay, cool. You're off and running. Remember that if you see an equation that is a negative in front, I gave it a name. Max. That one is a max. So I know if I graphed it, it would have a like upside down parabola, and therefore it would have a maximum point. If there's a negative in front, he's a max. Okay, good enough on that. That's all I got for the video for today.